Hello friends, let us discuss about stress. Now in previous video we have seen what are the different forces or loading which is acting onto the object. Now we have seen that whenever there is external loading, body it will get deformed and it will try to oppose it. So that resistive force offered by a body per unit area is termed as what? Stress. Okay, this stress, it is a tensor quantity. Okay, it is not a scalar, it is not a vector, but it is a tensor quantity and it is denoted by a notation sigma. Okay, now there are basically two main types of stresses. One is normal stress and second is shear stress. So in this video we are going to see what are the normal stress. Now normal stress means normal force divided by cross sectional area, and normal force means a force which is acting perpendicular to the surface. Now let us consider this is the body. You can consider a rectangular or a circular body, and P is the external loading. Okay, so if we take a cross sectional area, okay, this will be what? This will be your cross sectional area. Okay, you can denote a cross sectional area by A. So whenever there is external loading, body it will get deformed. Now this is which type of loading? It's a tensile force. Tensile force means it's a pull type of force. Okay, body it will get pulled. Okay, there are two things, one is pull and second is push. So this type of loading, that is, it is going away from the body, that means body it will get pulled off. That means there will be increase in the length of the body and there will be decrease in the diameter of the body. Now whenever external loading is acting, body it will get deformed, it will try to resist it. That means it will produce some resistive force. That resistive force is what? It is denoted by R. So this R divided by cross sectional area is termed as what? Stress. Okay, now definitely this R, it is going to be equal and opposite to that of P. So we can write, instead of R we can write P, and A will be area. So force or loading, it will be measured in Newton and area will be in meter square or mm square, millimeter square. So what will be unit of stress from this? It is Newton per meter square. Now this is what? This is tensile type of stress. Now in the second figure, let us consider a same body. Now let us consider magnitude of force is same, that is P, but instead of pull, let us consider it's a push type of force. It is what? It is a push type of force. Okay, so whenever there will be push type of force or whenever there will be a compressive force, there will be decrease in the length but there will be increase in the diameter. So again body will try to oppose it. See why body is going to oppose it? Because see, any body want to remain in what? State of rest. So whenever there are external loading, so it is going to oppose it. So again body will produce a resistive force of magnitude R, which will be equal and opposite to that of P. So again we can define compressive stress here, that is equal to R divided by A. Again we can write, instead of R we can write what? P here. Okay, so again compressive stresses, unit will be what? Newton per meter square. So this is this two, that is tensile stress and compressive stresses. These are which type of stresses? These are normal stresses. Okay, see why it is called as normal? Because if you observe loading here, this P, it is acting what? It is acting perpendicular to the surface. Again this force, it is acting what? Perpendicular to the surface. That's why it is called as normal force, and corresponding stress is called as normal stress. Now second type of stress is called as what? Shear stress. Okay, now what is shear? Okay, let us consider a riveted lap joint. Okay, in a simple language you can consider, suppose this is one plate, let us consider this is a second plate. Now these two plates, these are joined by using a pin, so it's a riveted lap joint. Okay, and let us consider P, it is a tangential force. Okay, now if you consider this area, suppose if you are considering this area, these forces are what? These are tangential, these are acting what? Tangential to the surface. Okay, so whenever you will find such type of forces, it is going to produce a shear stress. Okay, we have already defined what is shear force. Shear force is what? It is parallel to the surface. So here you can find it is what? It is parallel to this surface. Okay, so again body will try to resist this. Okay, so first plate and second plate, they are going to slide upon each other. Okay, you can see here sliding action. Okay, so first plate, it will slide onto the second plate. Okay, so again it is going to produce what? Resistive force. It will try to resist this change. That resistive force per unit area is called as shear stress. So how we can define a shear stress? It is denoted by tau. So it is equal to shear force divided by cross sectional area. Okay, so resistive forces are divided by cross sectional area. So again, what will be the unit? So force will be in Newton and area will be in meter square or mm square. So unit of force, it will be what? Newton per mm square. Okay, so hope you have now got the clear idea what is normal stress and what is shear stress. Okay, so if we can draw FBD of this pin. Okay, so these are the shear stress. Okay, you can see here this shear stress, it is what? It is tangential or it is parallel to this surface. Okay, so if this shear stress produce, if it is becomes more, then there may be or it may lead to failure of your lap joint. Okay, so in the coming lecture we will see it. For time being, just remember what is normal stress and what is shear stress. Now let us discuss what is the sign convention for the stress and what are the units of stress. So normal tensile stress, it is considered as positive. So tensile stress is considered as positive. Second, normal compressive stress, it is considered as negative. Now what about shear? Okay, now a shear which will produce a clockwise couple is considered as positive. Okay, you can see it's a clockwise. It is going to produce what? A clockwise couple. And a shear which will be produced an anti-clockwise couple. Okay, it is considered as negative. What is couple? Basically couple, it is what? Force into perpendicular distance. Okay, now let us discuss about units. So unit we have already seen, it is what? Newton per meter square or Newton per mm square. So you have to remember this unit conversion, that 1 megapascal, it is equal to 1 Newton per mm square. 1 gigapascal, it is equal to 1 kilonewton per mm square, and 1 gigapascal, it is equal to 10 to the power 3 megapascal. So remember this unit conversion. This will be helpful. It will save your time while solving a numericals. So hope you have cleared about what are the normal stresses, what are the shear stresses, and what is the sign convention and unit of stress. So thank you very much.